alloys, right? So I think we did this before, but we just go through again quickly, just to remind you. Um, of course, the first thing you need to know, because you're doing material science, so you need to know what's the difference between element, compound, composite, polymer, different materials. You should know about them. So the elements are made up of atoms, which is the smallest particle that has any of the properties of the element. So it is the smallest particle making of all the matter. Smaller than atoms. Of course, you know atoms consist of electrons, protons, and neutrons. That doesn't give the properties of that material. So the smallest particle which is giving the property of the material is called element. So an element is a substance that's made entirely from one type of atom. This is important to know. It's only one type. For example, water is not element. Why is it not element? Because it consists of two types, oxygen and hydrogen, and they are different. But this oxygen and two hydrogens, they combine with each other. In other words, two elements combine with each other to making something is called compound. So compound consists of at least two different elements. So an atom is the smallest unit of matter that has the properties of an element. So what's the smallest particle which represents the properties of an element is the atom. It's composed of a dense core called the nucleus and a series of outer shells occupied by orbiting electrons. I believe this is very basic, and you know that. Atom consists of a nucleus and electrons orbiting around the nucleus. Of course, the nucleus is composed of protons and the neutrons. Of course, Dalton is the first person who proposed a modern theory of the atom based on the following assumption. He assumed the following things. Number one, he said matter is made up of atoms that are indivisible and indestructible. What Dalton thought, he thought that we cannot divide atoms into smaller particles. At that time, that was the idea of Dalton, but nowadays this is not true. All atoms of an element are identical. This one is could be by some way is correct, and by the other way could be is not correct. Why is it not correct? Because atoms for the same element, most of the atoms have isotopes. And you know isotopes are the same element, they have same proton number and same electron number, but they are different in the number of neutrons. So that's why we can say yes, could be identical in having same number of protons and the electrons, but they are different in the number of neutrons. So they are sort of not identical. And this is because at that time they didn't know about the isomers. They have, sorry, isotopes. They didn't have any idea about isotopes. Number three, atoms of different elements have different weights and different chemical properties. That's true. For example, oxygen is not similar to hydrogen, hydrogen is not similar to chlorine, chlorine is not similar to sodium. They have different weights and they have different chemical properties. Some of them very active, some of them just active, some of them they are not active, so they are different. Atoms, number four, atoms of different elements combine in simple rule number to form compounds. For example, one oxygen atom combined with two hydrogen atoms to make one compound which is called water. Another example, sodium, one sodium combined with one chloride to make sodium chloride. Or, for example, hydrogen peroxide, two hydrogen atoms combined with two oxygen atoms to make hydrogen peroxide. So number of atoms combined with another number of atoms to make compound. And the compound maybe consist of two atoms or three or four or five. Atoms cannot be created or destroyed. When a compound decomposes, the atoms are recovered and changed. Yes, you can decompose, for example, water again into hydrogen and oxygen. So this is generally the assumption about atoms. First, we started thinking about the model of atom. And compounds, as we say, a pure substance. Remember, that should be pure. If it's not pure, if it's mixed, two or three different things and not combined with each other, so it's a mixture. It's not a compound. So it's a pure substance consisting of two or more elements chemically combined. They're combined in a chemical way. When we say chemical way, we mean they make a bond, like covalent bond or ionic bond. Of course, in a definite or a definite composition. It means the composition is known. Example, hydrogen peroxide is two hydrogen and two oxygen, and that's it. That can be broken down into a simpler substance. For example, we can break down hydrogen peroxide to oxygen and water, for example, and then we can decompose water to hydrogen and oxygen again. Of course, this decomposition of a compound to its elements should be a chemical methods, not physical methods. When you boil a water, it changes only from liquid state to gaseous state, which we call it vapor in this case. So that's a physical change, that's not a chemical change, because the vapor is still water, is still H2O. So chemical methods of separation such as electrolysis, redox reactions, and catalysis. As we said before, compound, ionic compounds, we have ionic compound. For example, metals often react with non-metals, usually metals, and the metals on the periodic table, they are on the far left, and the non-metals, they are on the far right. So more you go to right, more non-metallic character, and more you go to left is more metallic character. So usually when you have a metal with non-metal, they form ionic compound. A very good example is sodium chloride. Sodium chloride, sodium is a metal, and chloride or chlorine is a non-metal. So these compounds are composed of positive and negative ions. That's why we call it ionic, because it's two sides. One side is positive and the other side is negative. And because they have different electric charge, they attract each other, bonding with each other, making one compound which is called, for example, sodium chloride, sodium ion combined with chloride ion, which is negative, and because of the sodium is positive, so we have two ions having two different charges, and that's why they combine with each other, forming a bond called ionic bond, and that's why we call them ionic compound. The other type of compounds is called covalent. Non-metals combine with each other. In this case, we have the non-metals, for example, hydrogen with chloride, although some people they don't consider hydrogen as a non-metal, but that's not the point. You have, for example, oxygen or nitrogen or chlorine, that's all non-metals. They might combine with each other. For example, nitrogen with oxygen, they making nitrogen oxide. So non-metals combine with each other to form covalent compounds, which exist as a neutral molecules. This is, as you can see, sodium ion with sodium with chloride ion. They combine with each other. Each ion, sodium or chloride, has six nearest neighbors of the opposite sign, resulting in the present structure. Look at the sodium, look at the chloride. The chloride is the bold one, and the sodium is the faint one. So we have sodium with chloride. If you look carefully, for example, to this sodium is surrounded by six chloride. This is one, this is two, this is three, this is four, and this is five, and this is six. Same as for sodium, surrounded by six chlorides, and the chloride surrounded by six sodiums. So because the ratio is 6 to 6, 6 sodium ion and 6 chloride ions in this crystal form, which is called giant structure. So that's why the formula for sodium chloride is NaCl. It means for each one sodium ion, there is one chloride ion, and this is because the sodium has only one charge and the chloride has only one charge, so it is 1 to 1. So in general, the properties of ionic compounds, yeah, ionic compounds, ionic bonds strong, and they are usually solid, and they have high melting and boiling point. They made a metal and non-metal, made of metal and non-metal, so they conduct electricity when they are in a solution or melted, but they don't when they are in solid state. Okay, as we said about covalent bond, this is covalent bond. Look at the oxygen has 6 electrons in the outer shell, and hydrogen has 1 electron. So one oxygen can combine with two hydrogen atoms, making two bonds. This is one, this is one. Each bond is pair of electrons, 2 electrons. One belongs to the oxygen and one belongs to the hydrogen. And now if you look at the outer shell, for the oxygen is 8, which is octet number, so it's full. And the hydrogen is 2 because the hydrogen electron level is only one level, which is the first level, 1s, and occupy maximum 2 electrons. So now these 2 electrons, which is cross dot, or cross circle. If you see, one represent cross, one represent circle. Both are electrons, is not different, but we just do that to show you the difference or distinguish between which electron belong to hydrogen and which electron belong to oxygen. But when they might make bond between, for example, in this example, between oxygen and hydrogen, so now these two electrons is belong to the two atoms. It's not belong to only one. Is a sharing bond. These two electrons, these two pairs, you have two pairs, one pair between hydrogen and oxygen and the other pair between the other hydrogen and oxygen. So these electrons now are sharing for both atoms. That's why it's called covalent bond. So about some important properties of covalent compounds. Uh, Usually covalent compounds, they might exist in as a solid or as liquid or gases at the room temperature. Neither pure covalent compounds nor dissolved forms in water don't conduct electricity. Usually they don't conduct electricity, therefore covalent compounds are poor electrical conductors in all phases. It's not like ionic compounds. So ionic compounds are very good conductors in general, but the covalent compounds, they are not. Most of covalent compounds are soluble in nonpolar solvent. Nonpolar solvent example, like toluene, for example, ethanoic acid could be, no, sorry, ethanoic acid, that's not a good example. Let's say benzene, for example, but not in water. Oil, for example, but they are not soluble in general in water. Generally, they are softer than ionic solids. So ionic solids, ionic compounds, they are harder, stronger, and they have in general low melting and boiling point. And because we said they are either solid or liquid or gases. So when they are liquid or gases, if you compare them with ionic compounds, so they have low melting and boiling point. Now, what we mean by formula, what is formula? Formula, a molecule is the smallest particle that has any of the properties of a compound. So the smallest particle for a compound which still has the property of that compound is, of course, as we said, composed of elements in certain ratio. For example, as we said, hydrogen peroxide, which is H2O. So it means you have two hydrogen atoms combined with two oxygen atoms in this compound. So this H2O, we write it is a formula, means formula. And the formula for any compound must be neutral, not charged, otherwise it would be ion, the formula of ion. So the formula for a compound has no charge, but for ions has charge. So when writing when writing the formula for an ionic compound, the charge on the ions must balance. For example, sodium chloride, we don't write charge because sodium is one positive and a chloride is one negative. So they balance each other, they cancel each other. So the number of positive charge must equal the number of negative charge. When you write calcium chloride, which is CaCl2, so you have one calcium has two positive charge And one chloride has one negative charge, and because there are two, so you have two chlorides, it means two negative charge balancing one calcium, which is two positive charge. So you have two positive charge on calcium, and you have two negative charge on two chlorides. This we're giving you examples. We're giving you examples here. CaCl2, you have two positive charge, as I said, one calcium ion with two positive charge and two negative charge from chloride, so that's why CaCl2. You have another example, aluminum sulfate. Sulfate, only sulfate, which is SO4, has two negative charge, and aluminum, one aluminum has three positive charge. So you need two aluminum to balance three sulfate. So in total, you have six positive charge on two aluminum, and you have six negative charge on the three sulfates. So that's why it's balanced. And now what about mixtures and compounds? The law of constant composition, what it means, states that the ratio by mass of the elements in a chemical compound is always the same. So if you take any molecule of water, any molecule of water, they have the same ratio of hydrogen to oxygen, the constant, no change. And of course, that water could be any water, regardless of the source of the compound. So the law of constant composition can be used to distinguish between compounds and mixture. Mixture has no certain composition, could be any composition. For example, seawater is a mixture of water and salt, different salts. So that's like a mixture. Right. So the law of constant composition can be used to distinguish between compounds and mixtures of elements. Compounds have a constant composition, mixture don't. Mixture could be any ratio, could be any amount, two, three, four compounds, or compounds with elements. It has no constant composition. So water is always 88.8% oxygen. That's the mass. Remember, we're not talking about the number of atoms. The number of atoms in water is two hydrogen to one oxygen. That's the number. But now we're talking about mass. So water is always 88.8% oxygen and 11.2% hydrogen. Any water molecule. Of course, we're talking about when the water is pure, not mixture. This is, sorry, brass is an example of a mixture of two elements, copper and zinc. It can contain as little as 10% or as much as 45% zinc. So different percents could be any percentage. The another difference between mixture and compounds of elements is the ease with which the elements can be separated. Of course, to separate the elements of a compound, you need a chemical methods in general. Mixtures such as atmosphere. Atmosphere is a mixture, nitrogen and oxygen, and very few percentage of other gases like carbon dioxide or water vapor contain two or more substances that are relatively easy to separate. Separation of nitrogen from oxygen can be by physical methods. So the individual compounds of a mixture can be physically separated from each other. So separation of mixture is usually can be done by physical methods. Of course, chemical compounds are very different from mixtures. The elements in a chemical compound can only be separated by destroying the compound. You cannot get the compound if you want the element. For example, if you want the element of water, you change it, separating oxygen from hydrogen. At that time, there is no water left. It means you destroyed, you completely converted to something else, something different. So let's talk about composition of mixture, variable composition. Remember the word variable for mixture. The relative amounts of the two gases can be changed. For example, you have two gases mixture. You can change the composition, the ratio as you wish. But in compound, it has constant composition. Look at these two words. That's variable composition. That's constant composition. Okay? Water always contains the same ratio of hydrogen to oxygen. This ratio is shown in the chemical formula of the compound, H2O. Are they joined or not? The hydrogen and oxygen are not joined together. They exist together, but they're not combined with each other. That's in a mixture. So we have a hydrogen gas separated from oxygen gas. In compound, the hydrogen and oxygen, for example, in water, they have joined together to form a new substance, which is not hydrogen and which is not oxygen. It's different than oxygen and hydrogen. So that's the differences. If you look at the properties, keeps, talking about mixture, keeps the properties of the substances involved. This mixture is in the gas state. Properties in compounds are different from those of the element it contains. This compound is a liquid. We're talking about water in this case. In the other case, with mixture, we're talking about, again, hydrogen and oxygen. When they are as a mixture, they exist as gases because hydrogen is a gas and oxygen is a gas. But when they combine to make the compound, they change to the liquid state, which is water. How we separate them, hydrogen and oxygen, for example, the substances in the mixture can be separated easily, but in compound cannot be separated but can be obtained by using chemical reactions. I think we did this before. If you look at this example, I think this is a good diagram showing you what's the difference. If you go far left, this one, look at this one, you have two different atoms combined with each other and all are same. This is same as this one, and this one is same as this one, and this one is same as this one. So this is a compound, not a mixture. This is a compound, this is compound, this is compound, this is compound. This one, look at this one, you have these, and you have this large circle, but there is no combination between them. This is not combined with this is not combined. There's no any combination between any two. So because this is the smallest particle, it's not combined with anything, so these are atoms. So this is an element, and this one is an element as well. It's not compound, but because two different elements exist with each other, and they're not combined with each other, so it's a mixture. And because it's a mixture of two elements, usually we call them alloy. So alloy is a mixture of at least two elements. Look at this one. You have this atom combined with four atoms, so that's definitely compound. This one, this atom is combined with this atom, but they are the same type, so this is element. This is not compound, it's an element because the two are identical. So we have compound, we have element, compound, compound, element, element, element. So this is a mixture of elements and compound. If you look at this one, you have again two atoms combined, but they are identical. This one, this one, this one, this one, and this one, and lastly this one, all of them exactly similar to each other. So these are molecules because these two atoms, when they combine, we not call them atom, we call them molecule. So molecule is a combination of atoms. So this one is a molecule, this one is a molecule, but it's a molecule of an element, not compound, because they are identical. So this is molecule of element, pure element. It is not mixture. Now look at this one. Again, you have this atom and this atom, this atom. So this is not combined with any other atom. And in this one, you have two atoms combined. Two atoms combined. So this is a molecule of an element, and this one is an element. And because we have two different types of elements, so this is a mixture of two elements. So how we distinguish between pure substances and mixtures? Pure substances have a sharp melting point, very clear, but mixture have like a range of temperature. When you melt them and you're measuring at what temperature they start melting, you will see that melting would happen in a range of temperature. So that's not a pure. This is one of the techniques we use in the lab to see if our material we prepared, for example, especially with organic compounds, to see if it's pure or not by doing this experiment, melting point. If it's very sharp, it gives you an idea that material is pure, is not a mixture. The difference is most easily seen when the temperature of a hot liquid is measured as it cools and freezes. This one, look at this one, this curve, doesn't mean that's the temperature. We're cooling some material from about 85 centigrade, for example. So when it's cooling, the temperature is going down by the time, like a curve, and that's a liquid cooling. It reaches somewhere, it would start freezing, something about could be 45, something like that. So start freezing. At freezing, the temperature doesn't change. The temperature doesn't change. So that's why it's parallel to the time axis. And then start again after freezing, finishing freezing. That's solid cooling. Start to change to solid. And the curve again goes down. So the temperature stays the same while a pure substance changes state. That's, for example, melting point 45. Of course, if you go this direction, heating up, the melting, if you go this direction, cooling down, is freezing. or solidifying. Okay, this is okay. Now let's go to the alloys. Alloys, solid solution. This is a good word to remember it. Solid solutions. Many people think when we say a solution, they think it's a liquid. It's not necessarily to be liquid. It could be gaseous. It could be solid. For example, air is a solid. Sorry, sorry. Air is a gas solution. Alloy is a solid solution. Solution means you have solvent and solute. You have two things. The majority, the major one, let us say, the major one is the solvent and the minor one is the solute. So an alloy is defined as a combination, mixture, homogeneous mixture of two or more. Of course, when you say mixture, must be something at least two. If it is only one, so it's not mixture. So of two or more elements, of which one of the elements should be a metal in major proportion. One of them should be the metal and should be the major one. That's the definition of alloy. So the others could be metals or non-metals. You have a good examples. You have brass, copper, and zinc. Copper is C capital. That U should be small. I'm sorry, by mistake. That U is capital, which is not right. Should be small, like this one, same as this one. And you have steel, of course, it consists of iron and carbon, a low percentage of carbon, and solder, which is lead and tin, and bronze, which is copper and tin. So what we mean by solid solution? Solid solution formed as a result of adding of impurity atoms to a metal. When we said impurity atoms, we have mainly a metal like carbon. In this case, is carbon, which is non-metal. You add it to iron, which is metal. A very few percentage, very few percentage. So it makes like a solid solution. It is an alloy in which one element is dissolved in another to form a single phase structure, homogeneous. It's one phase, all solid, without changing the crystal structures, and no new structure are formed. The structure for that ion is same, but that carbon, it goes just through. Okay, right. So we have like two types of solid solution. One is called substitutional and one called interstitial. Interstitial solid. Okay, I think I stop here, give you a chance to review this, and we finish the rest for for the next session. Okay, thank you for listening. Remember, we up to page 7. We do next session from this page, page 8. Okay, thank you very much.